Hello viewers, you're welcome to my page once again. In today's video, we'll be looking at vector, 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 vector. I'm going to make series of videos as related to vector, solve different problems on vector. So follow my page as I'm going to be updating it with different videos on vector. So in today's video, we'll be looking at this simple problem from one of the past questions. We have three vectors. 3 meters per second, which is in the direction of north 45 degrees west. We have 12 meters per second in west direction and 5 meters per second south, all of them acting at a point. So we have to calculate the resultant of what? The vectors. So before we do that, let's look at these three vectors and see how they actually act. Let's define a point. Let's say this is the point. Let's say this is a point where the three vectors are acting. The first vector is acting northwest. This is our north, east, southwest at an angle of 45 degrees. Here is also 45 degrees. So this is 3 meters per second. Then the second vector or the other vector is acting towards west. And the value is 12 meters per second in the western direction. You can see as I'm representing this, the length of the 12 meters per second is longer than 3 meters per second because it is higher in magnitude. So take note of that. Then we have the 5 meters per second acting in the southern direction. So these are the three vectors. I have not done anything, I have not solved anything yet. All I did is just to represent the question, just using a diagram to rewrite the question. So I'm going to translate this diagram into what? A vector diagram. Into vector diagram. So in the vector diagram, this diagram will translate to, let's take each of the vectors one after the other. Let's define the point here. And you have the first vector moving. This is 3 meters per second. This is 3 meters per second in the northwest direction, 45 degrees. So here is 45 and here is 45 degrees. So from the head of this one, where this one stops, we will take the second one, 12 meters per second. So 12 meters per second is acting. If we define our cardinal point here, if we define another cardinal point here, the 12 meters per second is acting towards west. So this is 12 meters per second. So from where this one ends, we take from the head the 5 meters per second, which is acting south. So this is 5 meters per second. I'll say 5 meters per second. So this is the vector diagram for this vector. Now, this is where we started and we stopped here. So our resultant, which is what we are calculating, is the line joining where we started to the point where we stopped. So this is the resultant from where we started to where we stopped. So this is the resultant. So let's find the value of that resultant. But before we do that, we need to join here to here. So I'll have two triangles in this diagram here. Let's call this place X. You can see these line and this line are perpendicular. So this is 90 degrees. So this is a right angle triangle. So using Pythagoras theorem, we can find the value of this right angle triangle. And how do we do that? We can find the value of this X by using Pythagoras theorem. So X squared is equal to 12 squared plus 5 squared. So X squared is 144 plus 25. X squared is equals to 169. X is equals to square root of 169. And that gives us 13 meters per second. So here is 13 meters per second. Remember, that is not the resultant we are looking for, but we need it for us to be able to find here. So for me to find here, I'm going to use cosine rule. And for me to use cosine rule, I need to find the value of this, the whole of this angle here. Remember, this angle here is alternate to this one. Alternate angles. Let's see if I have two parallel lines with their transversal. Now, any angle made in such a way that it tends to take the shape of n, and the angles formed in this way are said to be alternate. If you also have two parallel lines this way, and this is their transversal, this angle is alternate to this. So this north-south line is parallel to north-side line here. So this is their transversal. So if here is 45 degrees, here is also what? 45 degrees. Right? Good. Now we need to find here. Please, we can't assume that this line is coming exactly midway. So we can't make such assumption. So we need to find the value of this place. Let me call it theta. Let me call here theta. Let me call him beta. If I know the value of this, subtract it from 90, I will know this. Why? Because this is west and this is south. So it is 90 degrees. Good. So we're going to use SOHCAHTOA to find the value of theta. So we have now that tan theta is 5/12. So theta is tan inverse of 5/12. If you get the tan inverse of 5/12, that gives us theta as 68.2 degrees. That is the value of what theta there, 68.2 degrees. So here is 68.2 degrees. Recall that alpha plus, beta plus theta is 90 degrees. So beta is 90 minus theta, which is 90 minus 68.2, and that gives us 21.8 degrees. So here is 21.8 degrees and here is 44. The whole of this angle is now 66.8 degrees. So if I add this and this is 21.8 and this is 45. We have what? 66.8 degrees. Okay. Now let's now apply cosine rule. So if I bring out this triangle here, so what I have, if I bring in that triangle, we have something like this. Here, this is 13 that we calculated. This is the R we are looking for, and this is 3 meters per second. Now this angle is 66.8 degrees. So recall cosine rule. Cosine rule, if you have a triangle of the form with here A and the side facing a small letter A, you have here is B and here B. We have this here C and the side facing a small letter C. The cosine rule states that A squared is equals to B squared plus C squared minus 2BC cos A. So if I'm looking for here, the square of this is equal to the sum of the square of this and this times, minus 2 times the product of this and this, cos the angle opposite the side I'm looking for. So the same way, if I want to find B squared will be equals to A squared plus C squared minus 2AC cos B. If I want to find C squared is equals to A squared plus B squared minus 2AB cos C. So we're going to apply the same concept here. We are looking for here. So R squared will be equal to 13 squared plus 3 squared minus 2 into 3 into 13 cos 66.8. Are we good? So here, to resolve all of this will give us 178. This into this will give us 30.73. So R squared 78 178 minus this is 147.27. So R is equal to square root of 147.27. So R is 12.14 meter per second. So the resultant of these three vectors is 12.14 meter per second. I trust you enjoyed the video. If you did, please click the like button and share with your friends. Do try to follow for my next video. God bless you. Bye bye. Hey.